Bismillahirrahmanirrahim. Dear fellows, Assalamu alaikum. I am Shabana Naz from MPhil second semester, Department of Computer Science. Today I am going to discuss Z specifications for a telephone network system. I have chosen the telephone network system for my presentation. So let's start. Going into the detail of this presentation, let me first give a brief introduction of the system which I have been supposed for the Z specification. So the telephone network system is such a system in which connections may be established between pairs of telephones. Here, one phone can make a connection with another phone. Now, taking this connection, a phone will make a request, or we can say that a request is made first. So a request may be made for the connection of a given phone by any other phone. Now this request can be satisfied or dissatisfied. If the request cannot be satisfied immediately, it will be stored by the network and it will be satisfied later on. For the specification of the telephone network system, we will take three network operations for this system. The three network operations are call operation, hang up, and engage. So the call up means that whenever a particular request for a connection is being made between the two telephones. Hang up means to terminate a connection, and engage means that whether a given telephone is currently engaged, and if so, then with which phone it is engaged. So this is the system which I have been supposed for the Z specification. So let's start further in more detail. Okay, so for the Z specification of the telephone network system, first of all we have to consider a set of telephones. In this specification, whenever we consider a set, we will declare the set within the square brackets to represent our set definition, right? Okay, next is we define a connection to be a set of phones. Now, if you want to define a connection to be a set of phones, we have to make this connection equal to power set of phone. Now here power set is taken, which means that connection can be 0, it can be 1, 2 or more. Now this definition allows the possibility of conference calls in which more than two connections are possible. Suppose let us take a connection C such that number of connection will be greater than 2 for a conference call. It could be a test call. If a system is checked for some maintenance purposes by the staff, so at that time the number of connection available will be 1, and even it could be an empty call is also possible. So connection is it is a set of all possible subset of the phone set. Okay, the state of the telephone network is described by the two variables. Now here we are going to describe the state of this system by two variables, in which we are having request and cons. Now request is again a power set of con, and cons is also a power set of con. Now here the request and cons both are the power set of con, means they can be empty, they can have one or more requests, and there could be empty and one or more connections in these sets. Okay, the set of connections requested but not yet terminated. Now this request variable will represent the set of connections which are requested but not yet terminated, and cons means the set of connections currently active. So cons will represent active connections and request will represent the available requested connections but which are not terminated yet. And these are two state variables for our system. Okay, now these variables will satisfy some invariants as well. Invariants are the conditions which needs to be true all time, means before the operation and after the operation. If certain operation has been taken by the system, so invariants needs to be true, and after the operation it also needs to be true. So these two variables will have to satisfy the two invariants here. The first invariant says that cons is the subset of request. Now what does it mean? It means that only requested connections are active. So connections is the subset of the requested. We will have so many requested connections, but among those requested connections, only active connections, only requested connections need to be active. So we say that only requested connections are active. So this first condition says that the cons, which are connections, that is the subset of our requested connection. Now here the requested connections will be a lot, will be more, but active connections will be a subset of those requested ones. And the second one says that no phone may engage in more than one connection at any time. Now here the Z and Z we will represent this condition as cons belong to disjoint. Now what is disjoint? Disjoint is actually the power set of power set, mean it is the set of sets. So we say that disjoint is a set of sets, and it's the previous condition here which I discussed with you, that a cons belong to a disjoint, means that for all connections C1, C2 in cons is the set with having some connections in it. So C1 and C2 might be two connections within cons. It is necessary that C1 must not equal to C2. So if C1 and C2 both are not equal, implies that their intersection will be empty set. So the cons must belong to a disjoint. This says that a phone is which I have been discussed here, that no phone may engage more than one connection at any time. So in our Z we represent cons as the member of disjoint. I hope you will understand it. Okay, our state is described by the schema Tn. Now here Tn represent a schema name. We will say it telephone network, and the first section represent the variable section, in which the two variables which are our system variables, request and cons,